In this lesson, we're going to talk about logarithms. When trying to solve for an exponent, we need to use a new tool called logarithm. The logarithm of a number is the exponent needed to raise your base to in order to get your number. Let's take a look at that. So what we're saying is, if we have 2 to the x equals 8, what should x be? X is the logarithm of our number. Well, we know that 2 cubed is equal to 8, therefore we know that our exponent should be 3. We're going to talk about the logarithm form versus exponential form. Exponential form we've seen as number a to the x power equals b. Well, we can change from exponential form and rewrite that in logarithm form. We write log a, which is the base, b is the answer to our problem, equals x, x being the exponent that we raised our base a to get b. So 4 to the x equals 64, when written in log form, is log base 4 of 64 equals x. So log 464 equals x is read as, what exponent do I need to raise the base 4 to in order to get the number 64? Well, 4 cubed equals 64, so therefore x is 3, or the logarithm is 3. You should be able to rewrite the forms back and forth. We're going to take an example here of 5 squared equals 25. In log form, this is written as log base 5, that's a subscript, 25 equals 2. Versus log 232 equals 5 in exponential form, well, the 2 represents the base, so I have 2 to the 5th power, because the equal 5, that's our exponent, and it's supposed to get us the answer of 32. Let's talk about evaluating and solving logarithms. To evaluate a log means to solve for the missing number by converting to exponential form. Let's evaluate log base 10 of 10,000 equals x. So we're finding out what is the exponent that we raise 10 to in order to get 10,000. Well, 10 to the 4th is 10,000, so our x value is 4. Let's take a look at another example. Let's solve for log x 36 equals 2. Well, x is now in the base position. We know the exponent is 2, and we're supposed to get the answer 36. So some number squared equals 36. X is 6. Let's look at a third example. Let's solve log 2x equals 5. We're trying to find x. By putting it in exponential form, we see we have the number 2 of the base, we have the exponent is 5, and we're trying to find the actual number this comes out to be. So 2 to the 5th equals x. Well, x is 32. Now I'm going to have you try several types of these problems. First, you're going to write in exponential form, number log base 10 100 equals 2. We'll have you write a problem in logarithm form, and then have you evaluate and solve 3 logarithms for x. Pause the video, work through the problems, and when you're complete, restart the video and check your work as I go through them. Let's see how you did. Write in exponential form, log 10 100 equals 2. Well, again, 10 is the base. The number we're equaling to is the exponent, and the 100 is the answer we're trying to reach. The second one, we're going to write exponential into logarithm form. So we start with the word log. The subscript is our base. In this case, our base is 8. The number we're trying to reach is 64. The exponent needed is 2. Now let's take the next one. Evaluate log 7 of 343 equals x. So if I convert this, I have 7 to the x power is equal to 343. So in this case, our x value is going to be 3. Our next example, log x of 81 equals 4. So x is my base, 4 is my exponent that I'm trying to reach 81. So what number to the 4th power equals 81? X is equal to 3. And our last one, log 5x equals 3. 5 is the base, 3 is the exponent, and the x this time is in the place of the answer. So 5 cubed equals x. X is therefore 125.